So that's something about me. This was the most boring slide of the evening for you guys, because what we're actually going to focus on today will be some of the core concepts for data warehousing in Fabric. And yes, I say data warehousing, and no, I do not mean the warehouse storage engine that's in Microsoft Fabric. I mean the conceptual idea of creating a data warehouse using, in this case, lakehouses. So what we're going through is setting up a rule book for success, the ELT processes that we have to design, and then I will show you on slides and screenshots an end-to-end solution design with examples. We end up with some takeaways, and feel free to ask questions. If there's anything you'd like, as Craig mentioned, put it in the chat and he will interrupt me. I cannot see the chat right now, I think. No, I cannot. So feel free to put your questions in the chat. After the session, we will have time for Q&A as well. All right, let's dive into some of the core concepts that I think are important when we start thinking about designing a data warehouse solution or a data platform, regardless of the technology. So whether we're using SQL Server or Azure SQL with Data Factory or Synapse, Databricks, Snowflake, Fabric, and so on, it doesn't really matter. If you nail down these core concepts, you should be all right. So first of all, there are a few general design principles that I think are very important. This is not coming from me, this is coming from theory. And the first design principle that we want to have our data warehouse adhere to is that it should be subject oriented, as opposed to an operational database where data is very transactional oriented, right? We have in our ERP system a warehouse order line or a GL transaction line table with all kinds of very transactional data, where in a data warehouse, I would want to group data by subjects, by finance and sales and HR and production and so on. Then I want my data to be integrated. I do not really care where my data is coming from, and very rarely you see that data is coming from just one system inside of a company. You probably are all aware that you need to combine data from many systems, and the data warehouse should be integrated. It should, for the end user, not matter whether your data is coming from Dynamics or any kind of CRM or HR system or bookkeeping or whatsoever. Then the data warehouse should be time variant as well. That means that we can analyze historical data, we can look at trends, we can do snapshots and so on. And it should be non-volatile, meaning the data should be read-only, except for the ELT process, of course. I mean, the process that is actually getting data out of your source systems and then transforming it, that of course should be able to write data into your data warehouse. But for other users, you should not be able to do that, except maybe for translytical workflows, maybe for some planning stuff like that. But the actual data, the actual numbers that you're reporting on should not be changed by the end user. Then I want to prepare and pre-calculate as much information as possible. And that means that I'm transforming the data sets that I get, the raw tables I get from the ERP and CRM systems. I want to transform them into something that contains business logic, that contains information about the world around us. It should have context on dimensions and on KPIs and so on. And all of that should be pre-calculated as far down into the architecture as possible, usually in the data warehouse layer, or in Lakehouse, what we call the gold layer of the Lakehouse. Why do we do this? Mainly because we can reuse that logic quite easily. So we can, of course, create a data dump out of our operational applications into Microsoft Fabric, and then just run Power BI over those tables and start doing all of the logic in Power BI. That will work technically most of the times. However, then if we do new reports or new semantic models, we need to recalculate and redo all of that business logic every single time. It will be hard to maintain. It will be very difficult to keep everything aligned. So preparing and pre-calculating all your transformations and business logic in the data warehouse layer would be quite important. And last but not least, I want my data warehouses to be the single source of truth for all informations in the organization. And in practice, this will work usually for small and medium businesses, maybe for mid-market companies as well. If you go into the larger corporations, this will be very difficult. I've worked for a telco in the Netherlands. I think they had 12,000 or 13,000 employees. So it was a decently sized company. And the last time I counted, they had 31 different data warehouses inside that company. So you can figure that the single source of truth there was very hard to spot, but usually you should have the goal of implementing a single source of truth for information with your data warehouse. So we keep these general design principles in the back of our minds when we start designing our lakehouse solutions using Microsoft Fabric. So this lakehouse that we've been talking about, when I gave this talk for the first time, it was a year and a half ago. Microsoft Fabric was a lot newer than it is today. So probably these days people have heard about Fabric, they have heard about OneLake, they have heard about lakehouses. But let's set the tone a little bit and let's look at what lakehouses are actually under the hood. In Fabric and in OneLake, we need tools to do a couple of things. Those couple of things are ingesting data. We want to have these big trucks coming in, putting data into our warehouse, right? We need to ingest data. We need to have processes and tools in order to do so. One of these tools that we have, or sorry, a few of the tools that we have are pipelines, notebooks, and maybe even data flows Gen 2. And we can use all of those components within Microsoft Fabric in order to get data into OneLake, to get data into our lakehouse. We need something to store data, to hold that data, and to have materialized data sets that I can query when I need to query them. We call it OneLake, and OneLake is really the underlying fundamental layer of all the storage engines within Microsoft Fabric, on top of which you can start building lakehouses. So OneLake is basically a blob storage account in Azure that is managed by Microsoft, and they are storing data for you. OneLake sits on top of that, and Lakehouse sits on top of that OneLake, and it will help you store things like delta tables and so on. But OneLake is the storage is where we can put all of our files, all of our tables, all of our structured and unstructured data. Then the third part is we need something to process the data that we're getting in. So you can imagine that you can dump raw data into your systems. Maybe you're smart and you do incremental loading, and then every time you load data, you get a folder with a timestamp, probably, with all these incremental data sets. So for every table in your ERP system, you might get only the new records and changed records. And that will be very difficult to do reporting on or to do AI on. You need something that can process those incremental loads into your historical data set, what we call the silver layer, or what used to be called the persistent staging area in the past. And then we need to process that data into probably a dimensional model in the gold layer or the data warehouse layer of the data model. Of the data platform. And then for the processing, we usually fall back to notebooks where we write PySpark, which is Python with an API to the Spark engine that can actually interact with data on OneLake. Some of the concepts we have within Fabric that I want to go through with you guys before we can start actually building our lakehouses are tenant design, the storage layer, and then the compute layer. So tenant design, let's start there. At the top of your tenant, you will have the tenant, of course, that will be the one thing in your organization, the umbrella in your organization that everything will be put under. And on that tenant level, you have OneLake, and OneLake is what Microsoft calls the OneDrive for data. So in the past, you might have had a database here or a semantic model there or a data lake blob storage account over there in Azure. And your data would be highly fragmented across the organization. And for some analysis, you would pull data from place A, or you will pull data from place B. And now with OneLake, we say, okay, we have this OneDrive for data. The same thing as if you're writing a spreadsheet or a PowerPoint file and you want to share that with your colleagues, you're not emailing it to them from your hard drive, emailing it to their hard drive. No, you will put it on OneDrive and you will send the link to that OneDrive location. And the same thing happens with OneLake. You have one organizational level storage layer where you'll put all of your data, and from there you can then start pointing to data sets. Maybe a data set on OneLake is managed by one team or one department, another data set is managed by another department, and they can, if they allow each other, of course, then refer to each other. They can give these links to each other. One lake is only one lake, it's in the name, so that's on the tenant level. You cannot create multiple one lakes. Then when we go down into Fabric, we enter the domains, and domains is basically a grouping of workspaces with some settings and configurations and so on. Usually we do not use domains. I can see domains being useful when you have really large implementations, and where you have, I don't know, a strict segregation of duties, for example, between regions, for example, between functions, so finance and sales would be separate domains. In practice with our SMB and mid-market customers, we usually do not use any of these domains, but be aware that they are inside your tenant design. Now we trickle a level deeper and we then enter workspaces. And for most of you probably have been working with Power BI, you know workspaces from the Power BI portal, and workspaces in Fabric are actually the same thing. They are in the Power BI portal, a Power BI workspace that they simply call a Fabric workspace once you start running that workspace on a Fabric capacity. Okay, so the workspace holds all of your artifacts. It can hold your Power BI semantic models and reports, but it can also hold your lakehouse, your notebooks, your pipelines, and so on. Then inside workspaces, we can create folders in order to group items. That's more of a visual thing than it is really a physical thing, but it helps you organize stuff quite nicely. Then we get the artifacts, as I mentioned, reports, semantic models, lakehouses, notebooks, and so on. And those are the objects that we're actually developing. Those are the things that contain the code, that contain the data, that contain calculations and logic, and that will help us to really build up our data platform. And then the last piece in here would be that small triangle there, because I am not really great at PowerPoint, so I did not figure out how I could fit artifacts in the bottom of my triangle, so I entered that there. Throughout all of these, or maybe perpendicular to the tenant design here, we have compute capacity. So something I will touch on a little bit later is that we can, from the Azure portal, create a compute capacity or multiple compute capacities, and on the workspace level we will add those capacities. But it's a many-to-many relationship, so we can it's a one-to-many relationship, so we can run many workspaces on the same capacity, or we can choose to run only one workspace on that capacity. An example of lakehouses within your tenant would be something like this. So the outer layer, the outer box that I've drawn here is called my Fabric tenant. This is where the organization lives. And inside the tenant, I've created here schematically two different domains. One domain on the right side is called board reporting, and this is a domain that is very important. Board reporting should always be online, and people that are working in there should not have any downtime whatsoever. Also from compliance standpoints, I might want to be very sure who I'm adding to those workspaces. I might want to trace using Purview whatever is going on in these workspaces, and then I want all the other stuff that's happening on the data platform to happen outside of that domain. So on the left side, we've drawn a domain with workspaces that contain development, test, acceptation, and production environments. But it also contains a sandbox lakehouse for an intern, a sandbox lakehouse for, I don't know, machine learning maybe, and a sandbox for whatever. So you can see here that you can create many lakehouses within your tenant and within the domains that you have. And usually what we're doing is we're segregating these lakehouses out of the both the medallion architecture, so the separate layers in the data platform, the bronze, silver, gold. And we will also split out our DTAP environments. So we would have separate lakehouses for development and for production, for example. You can mix and match. You can mix and match, for example, saying, okay, I want my bronze lakehouse, which is the landing zone of all the data coming in. I only want that with just production. I don't care about having a separate storage layer that contains the exact same data just for development purposes. No, I can hook up my development code, my scripts, my notebooks over a shortcut to that production bronze layer. So sometimes you might end up with a slightly different architecture maybe. And then the same thing goes with your interns that you might give access to data, but you do not want them to be able to create downtime. You do not want them to write queries that mess up your data or that bring down your capacities. So maybe you give them a separate workspace with their own capacity, and if they bring that one down, then nobody is really impacted. But then how do you get your data into their workspace, right? How do you get your data in sync? That you can do that through shortcuts, which is, I think, one of the main features of OneLake and one of the nicest things for me as a data engineer to be working with. So segregation of lake houses by design is something I would do, and even across workspaces would be advisable. The reason to segregate by workspace is that your access control gets way easier. So it's very easy to say, okay, this group of people can access this workspace, and then automatically they can access all the lake houses that are inside that workspace. All right, let's zoom in a little bit to our storage layer in Microsoft Fabric. Now here on the right side, what we see is a schematic overview by Microsoft, not drawn by me, that describes how Fabric is set up. At the bottom layer, the base layer here, is called OneLake, and that is the storage layer underneath Microsoft Fabric, as I mentioned. Technically, it is just a blob storage account, but it's a blob storage account that can hold all the data in your organization and where you can put on many different storage engines. These storage engines usually work with the Delta Parquet format, and then let you as the user interact with them through several compute engines. So that's the layer that we have, is OneLake with several storage engines and then a compute layer on top, and then you have all your different workloads that you can run on top of those compute engines. I was looking for my mouse here. There we are. You only have one lake per organization, so if you want to split the access or the data storage between your between environments or parts of your data platform, you have to do so by workspace, by lakehouse, by warehouse, and so on. Storage is really cheap. In euros, at least, it's only 2.2 cents per gigabyte per month at the moment, at least in the EU data centers. Other data centers might have different pricing, and I think that pricing is updated on a monthly basis, reflecting the US dollar currency exchange rates as well. So your mileage may vary. Your storage bill might be a little bit different than those 2.2 cents per gigabyte per month. However, the story still holds that storage is really cheap. You can store many terabytes of data without really paying a lot of money to do so. Now the compute engines. You have a lot of data in your OneLake, you have your workspaces, lakehouses, warehouses, databases, and so on. You want to interact with the data. You want to read it, you want to transform it, and you want to write back data into that storage engine. There's basically four different storage engines that you can use. They are in the middle layer of this image, and they are called serverless compute. Why? They are included in your SaaS capacity. You do not have to spin up a server or a workload in Azure or whatever. They are included within your Microsoft Fabric capacity. Now, for data engineering purposes, you usually get a Spark cluster that is already pre-configured for you. So there again, Microsoft really tries to SaaSify your experience here and say, okay, you can just click, execute, next, finish, and you're up and running. You do not have to configure anything. You do not have to maintain or manage anything. You can, however, configure your Spark cluster to your custom needs. Now, besides the Spark cluster, there is the Spark engine. There are three other compute engines that are available within the compute layer of Microsoft Fabric. One, of course, is the TSQL engine that runs the Fabric warehouse storage layer, and it also runs the SQL endpoints that are sitting on top of your lake houses. So if you are coming over from a SQL Server background or an Azure SQL background, you can usually move into Fabric quite easily. There's no 100% feature parity, I believe, but the feature parity is getting quite close. So usually if you come from a SQL database point of view, you can quite easily migrate over that database and your stored procedures and views and so on, because you can run T-SQL inside Fabric if you use those workloads. Then the third engine is the KQL engine for Kusto databases. This is used for streaming analytics or real-time intelligence or real-time analytics or whatever name they call it this month. This has changed quite a bit in the past few months, but this is used for telemetry, for IoT streaming devices and things like that really output a stream of data. You can use KQL to store and query that data, to report on that data, and also to split off that data stream and materialize it on a lakehouse, for example, in order to have a long-term archive of all the streaming data that was coming through Kusto. And then the last compute engine is the analysis services engine. Maybe you've not heard about analysis services. That's really a SQL Server name. However, analysis services is the technology behind the Power BI semantic model, and that's something you probably have heard about. So every time you create a new data set or semantic model in Power BI, you start dragging and dropping the relationships, you start writing DAX measures, you're interacting with the analysis services compute engine. And that compute engine runs on top of the same Microsoft Fabric compute that all your other engines run on, and it can interact with the same storage layer that we have in OneLake. Now, compute is expensive. So where storage is really cheap, you can usually, without thinking too much about it, I mean, I would think a little bit about it, but not too much, you can dump in all your data into OneLake without any headaches of getting a large bill. However, compute is quite expensive, so you have to be smart about that. You can burn through a lot of compute really easily, and you can also optimize your code and your solution to use a little bit less compute, and then your CFO will be happy because then the Microsoft bill will be lower. All right, we've now laid out our tenant design and the things that we have at our disposal to work with and to think about. Now let's look at how we can actually enable a Fabric compute capacity, because if we do not have the compute capacity, we cannot do all the other things. So let's start by buying the compute capacity. We go through the Azure portal at portal.azure.com. And what I would do is I would create at least a resource group in Azure. Now, this is not an Azure session, but you have to understand that in your Azure tenant, again, you have multiple subscriptions and then resource groups and then resources, a resource being, for example, a Fabric capacity. I would usually create at least a resource group in order to call that thing data platform, add people that need to maintain it and to do monitoring on it. Maybe depending on your organizational requirements, you might even create a separate subscription. Now, billing happens on the subscription level. So if you have a certain cost center, for example, that you want the Fabric bill to go to, then create a new subscription, because then you will get a separate invoice for your Fabric usage. From there, you would then go to a new resource. You will type in Fabric and you will pick Microsoft Fabric from the list that you get, and there you can configure it. You can put that Fabric capacity in a resource group, as you can see here. You have to give it a name and you have to put in a region. Now you see West Europe being selected here because I'm very close to the West Europe data center. But you can choose any region that you want. In the European Union, we have something called GDPR, which governs that data should physically always reside within the EU, as if you are processing personal identifiable information, I think. So if you're processing addresses, dates of birth, credit card numbers, and such, you have to store your data physically within the EU. I'm not sure about other countries. Probably there are similar laws, so you have to think about where you will put your data. Other than compliance and legal requirements that you have for choosing a region for your Fabric capacities, you might want to think about latency. So picking a data center that's all the way around the globe might not be the smartest thing to do, because data will then travel a long way in order for you to actually work with it in your notebooks, in your scripts, queries, in your Power BI, and so on. So latency is a thing you might want. If compliance allows, you might want to pick a data center that's physically close to where you're working. And then lastly, pricing might differ between data centers. I know within the EU that West Europe, the one that I'm close to, is really expensive because it's full. Microsoft cannot install enough servers and enough GPUs and enough everything in order to keep up with demand in that West Europe data center. However, I know that in Sweden, the data center is underutilized. So pricing reflects that, and busy data centers are more expensive to work with than the less busy data centers. So if compliance allows, if latency and physical distance allows, then you can start looking at what is the pricing when I select one data center versus the other. Once you've selected your region, you have to select a size. And as you can see here, I've selected an F64. That is just an example. With most customers, we start on the lower end. And again, we're working with SMBs and mid-market companies. You can start buying a fabric capacity today from what they call an F2, which gives you 2 compute units, which is a very abstract way of saying you get this many compute. And then it doubles every time you go up to the next size. So you can order fabric compute in powers of 2, basically, from 2, 4, 8, 16, 32, and so on. I believe you can order up until a 2048, which is quite expensive, and this will run you basically a mortgage size bill every month in Fabric Compute if you start buying that F2048. The largest environment I've seen at a customer was a couple of F64s. The typical environment I see with customers is an F4 or an F8 for the smaller companies that we are working with. And that's just to give you an estimate, and I think the screenshots here are a little bit outdated. They are showing you amounts in euros, so an F2 would be 300 euros a month here, but because Fabric is priced in dollars and the euros are just the result of foreign exchange rates, I think at the moment with a falling dollar, the euro amount will be closer to 240 or 250 euros for an F2, and then again, depending on the data center that you're choosing, there might be a different pricing as well. The last thing you do in the center screenshot all the way at the bottom, you see Fabric Capacity Administrator. There you will pick at least one user that will be the capacity administrator, and no, you cannot use Entra ID security groups for that. This is something that is very annoying. And 2 weeks ago at MVP Summit, I spoke to the team that created this, and I really stressed that it would be very important to be able to use security groups for the Fabric administrator role. And they said they were looking into it, but they had a lot of other things to do as well. So I'm not sure whether that's coming and when it's coming, but for now we have to bear with the fact that we need to add individual users to that administrator role. Now, after we have deployed, we have to configure the capacity administrator, no Entra ID groups, as I said, and the one user that you picked during the creation of your capacity will be the administrator, but you can add additional administrators by using that big plus sign and the add button. It might make sense to start doing that, to at least have 2, 3, 4 people that are capacity administrators. And before you can create a Fabric workspace, which is the next thing that we're going to do. So we go to the Fabric portal or Power BI portal. When we start creating a Fabric workspace, once we want to assign a Fabric capacity to that workspace, you can only do so if you are a capacity administrator. So that's something you have to keep in mind. And this is basically what I just said. Yeah, the licensing type is something where you have to pick Fabric. So you can use Power BI Pro or Premium per user or things like that. We will pick Fabric capacity if we want to run Fabric workloads. Right. So I created the screenshot for Data Scotland because as I said, I recycled content. I did not create a screenshot for you guys. But then again, we created this Fabric workspace. And we can see the diamond icon to the right of the name. If you, this is just a screenshot, but if you would hover over that with your name, it would show Fabric content, meaning that this workspace is ready to hold Fabric artifacts, meaning lakehouses, pipelines, notebooks, and so on. All right. Next topic. Now that we have our tenant design ready, we have created our compute capacity, and we've created a workspace, or maybe many different workspaces depending on your tenant design. The next step is we want to think about this medallion architecture. And in the past minutes, I've already mentioned medallion a few times, and maybe I mentioned bronze, silver, or gold a couple of times. And this is coming from the medallion architecture. Now, medallion is not a Fabric specific concept. It is a data architecture that describes the 3 layers of data refinement or enrichment, and it calls these 3 layers bronze, silver, and gold. This is very arbitrary. We could have also called this 1, 2, and 3, or A, B, and C, or Jane, John, and Bas, whatever. It doesn't really matter. It's mainly meant to segregate the 3 layers of enrichment, and there we can say that, okay, maybe gold is better than silver and silver is better than bronze, so we call it bronze, silver, gold, because in gold will be the most highly enriched data, in bronze will be the most raw form of the data. As I said, this is not a Fabric specific concept. This is made popular by Databricks actually, and Databricks also did not come up with this way of working, but they made it really popular in their marketing and in their documentation and so on. Now, in practice, you will see a few different ways that people are working with the medallion architecture. In general, we can all agree around the world that the bronze layer should be for raw data only. And when we get data out of a source system from databases or APIs or files on SharePoint or whatever, we dump that raw data into the bronze layer. This is something that everybody and every data engineer that I talk to agrees on. Now, where the discrepancies start coming up is on the silver layer. So a lot of people say the silver layer should be to clean up your data and to prepare it for your star schema modeling or for your dimensional modeling. So what people will do there is they will start combining data sets. Maybe you have customer information in 2 different source systems. You will combine those 2 data sets into one and call it your silver layer customer data set. You would start checking for schema evolution, for all kinds of other data cleansing that you can do. And then in the gold layer, there again, usually people agree on what you should do there. You should usually model your data warehouse layer, or what we used to call the data warehouse layer data model, which is the star schema with fact tables and dimension tables. Now, in my company, we have a highly opinionated way of setting up these medallion architectures, and we are very strict in saying that we do not do any business level or data cleaning level transformations on the silver layer. We simply do not do that. So if we have 2 different source systems with customer information, we bring those 2 together in the gold layer, in the customer dimension, for example, in our star schema. What do we do in silver? We put in a historical data set there. So bronze will usually only contain the latest changes compared to the last time we've extracted data. So bronze is an incomplete data set. Now we have the complete data on silver, and bronze, the current bronze and the previous silver combined will be our fully historically accurate data set. So that's something we do on silver. Then we do persistent staging, what we call time travel on the silver layer. Usually when you get an updated record, you can overwrite values in that record. We say no, in silver we do persistency checks by default, and that means that if we get a record with a key that we already know but values that differ, then we create a new version of that record. Now Delta in Lakehouses, Delta Lake lets you do that automatically, but we do not rely on the Delta mechanism because it's really easy to break that mechanism. One command and your history will be gone. So we have recreated that ourselves in our silver layers. And actually it's quite easy to do. You simply check, is the key new? Then I insert a record. Is the key already existing? Then I check, are values changing? If no values change, I don't do anything. But if values have changed, then I put an end date on the current records. I insert a new record with the new values with a start date from today and an end date in the future. And then you can time travel through your data. Another thing we do in silver is we normalize data types. So usually you see the rounding of data times, the rounding of decimal data types. You do not need 12 decimals usually in monetary columns, for example. You do not need millisecond precision on timestamps of when an order was entered, usually. So the normalization of data types is something we do. And we also do schema evolution automatically in that silver layer. That means that if columns change or data types change, we automatically try to reflect that in the silver layer. If a new column comes in, We add that column to the silver layer, fully automated. If a column drops out of the source system, we will keep it in the silver layer, but simply stop loading it for new data. So then the records, the values for that column will show nil or none if there's if a column has dropped out. And the reason we do it like that in the silver layer is that we can generate our silver layer from code. We do not have to think about business logic of these two data sets. They describe the customer, so we need to combine them. No, we can easily now say this is just a table with a key and some columns and some data, and we can automatically roll out all of this history, time travel, data types, schema evolution, and so on. And in the gold layer, again, we do the dimensional data modeling. We write usually Spark SQL queries in order to do data transformations and write data into the gold lakehouse. So that's the medallion architecture. Now with Power BI, we can do direct lake connections. That works really, really well these days. In the past, it was a bit flaky maybe to use it, but these days direct lake is the way to go. So we do not need to copy any data into the Power BI semantic model. The Power BI semantic model can easily query the gold lakehouse. There we are. Now, with workspaces in the medallion architecture, usually what we will do is we will create one workspace per medallion stage. So as you can see here on the right side, we have a bronze, silver, and gold workspace. And in this case, you can see that there's also a dev in front of it for development. So that means that we also have development, test, and production in separate workspaces. You will end up with a lot of workspaces if you do it like that. But it will really help you set up very granular access control. So I can say, okay, my developers should be able to access everything. My end users should not be able to have access to the development workspace, for example, but an end user that is only allowed to do reporting should be seeing the gold lakehouse only. So they're getting access to production gold. Maybe a data scientist that needs to do any kind of deeper level analysis or statistical analysis on all the data that we have, they maybe get access to the production level silver layer, right? A key user that does end-to-end testing for us, they get access to to the gold layer on the test environment, right? So there we can really granularly set up user access. So that's usually how we set this up. Any questions so far before we dive into the first lakehouse solution end-to-end?
No, we've had no questions online, Bas.
Right. Then let's start looking at your first Fabric Lakehouse. We have prepared a small scenario where the client is a small B2B professional services company. They use two main softwares called Moneybird, which is an accounting software, and Odoo, which is an SMB ERP system, where accounting happens in Odoo, and all the other processes from sales and projects, timesheets, and things like that will happen in Odoo. Now they have a few data domains, or two main data domains I want to be able to do reporting on, which is finance and projects and timesheets. First, we come up with this rulebook, as I mentioned before in the introduction. So the rulebook will really help us to go back to the designs, that if we start developing things, and also if we get new colleagues on board, or if we have to redevelop stuff a year from now, we can remember the rules and the standards that we want to adhere to. So the rulebook we created is as follows. We will use Data Factory pipelines for orchestration. We will use PySpark notebooks for processing. So we're not going to copy data using the Fabric pipelines. We will only use the pipelines for orchestrating our processes. And then the pipeline can call the notebook, and then the notebook can run its code and do actual data transfers and data transformations. We want to have reusable code for everything. I do not want to write the same function twice, because that will be difficult to maintain. I have another talk on do not repeat yourself, and that's a very important part of this solution architecture. We want to use lake houses for storage, and that's about it. These are very high level rules, and we can dive very deep into any of these, and usually we do that with our clients. But for today, these are the main rules that I want to be following. Now, before we get started, we need some prerequisites set up. We need to have a Fabric compute capacity, and that was done a few slides back. We need to have Fabric workspaces set up, and that was done a few slides back. And we have to configure Spark, and we will skip that for today because usually in most instances, the default Spark configurations by Microsoft are quite okay. So you can tweak them if you know what you're doing, but we can skip the Spark configuration for today. Now, one important thing that we have to do is setting up the environment. And why is that important? An environment in Microsoft Fabric is a way where you can run custom software or custom packages from Python. Now, we do a lot of data engineering work using Python. And we also wrote our own Python libraries in order to extract data from very common SaaS software, for example. And we want to make sure that Fabric can connect to that code base. Now, Microsoft, of course, doesn't know about the Python code that I wrote, so they did not include my code into Fabric. By default, a lot is included in Fabric, but if you want to extend the code base of Fabric, you have to use custom environments. You can simply create an environment. It's one of the artifacts, like you can create a report or a lakehouse, you can create an environment as well. Now, if you want to include software that is in the Python package index, you can do that very easily. You do not have to download those packages yourself and then upload them, but you can simply integrate them from the package index, and you can also write and include your own code. Creating a new environment, as I mentioned, it's quite easy. You will pick new item, then you say environment, and then Fabric asks you to give it a name. I call this KDF usually for Kimura Data Framework, which is the product that we sell. And then we can start adding libraries in here. You can see on the top right, you have public libraries and custom libraries. Public libraries can read from the package index, and then you can import basically any Python libraries that you can think of in any version that's available to you. Now, mind you, a lot of Python libraries, I think over 200 or 300 libraries are already included in Microsoft Fabric, but Microsoft decides what version to include. If you do need, for whatever reason, a different version, you can do so through these public libraries. Now, if you want to add your own code, you have to create a Python wheel file. We're not diving into how that works, but that's basically a packaged up Python solution that you then can export out of Visual Studio Code or whatever development environment you're using. And you can then upload that wheel file to your custom library in the environment. If you've done so, then you can include any functions from your Python library into the notebooks that you run. So then you can have your own code and you do not need to rewrite every function in every notebook that you're developing. All right, so we have our three lakehouses. This medallion architecture, we already discussed how that works. And what we're going to do for this client here is we're going to say, okay, in our bronze layer, we will have timestamp folders with their incremental loads. Then we have raw data in files. They can be JSON files, XML, CSV, Parquet, and so on. If we read from a database, we will usually get Parquet files. That stores really nicely, it's compressed, it's efficient. And 9 out of 10 times, if you read from an API these days, you will get a JSON file, a JSON response, at least for most REST APIs. Once every while, you will find CSV files on an FTP server or a SharePoint. Less and less often, you will get XML files out of, for example, a SOAP API. Now, on the bronze layer, we're not storing tabular data. We're storing files, just raw files, okay? On the silver layer, we are creating this historical archive. We normalize the schemas, and we do so through schema evolution, through data type normalization, and we move all of our data into Delta tables. Now, Delta tables are a tabular data format that you can query as if it is a table on a database, but in the end, it is still a bunch of files on your data lake. So you get the cheap storage of the data lake and the queryability of a database, which I think are the best of both worlds. So bronze is still raw files. In silver, you will go into Delta tables, plus all the other enrichments that we do on that data. And then in gold, we have the prepared and modeled data warehouse tables. We have dimensions and facts, and then again, the storage is in Delta tables. How are we setting up the ETL process? We need to keep in mind the medallion architecture, and we start connecting to data to extract Moneybird and Odoo data into the bronze layer. We're not extracting into silver or gold directly. We're extracting into that bronze layer. We will do so through the use of Python, and we can execute that in Fabric notebooks and then schedule and run those in Fabric pipelines. So there's these layers that we can use. These layers visualized look a bit like this. We have our data factory pipelines, and they will orchestrate the process that we are trying to run. You can schedule your pipeline on that level and have error logging and monitoring and so on. Then the pipeline is starting off an orchestrator notebook. The orchestrator notebook will execute one or many worker notebooks using run multiple out of the notebook utils library that is created by Microsoft. Usually we will have a metadata or configuration data set that describes what these worker notebooks actually should do. But we can now run in multiple on the same threads a lot of notebooks at the same time, so we can extract many API endpoints simultaneously. This worker notebook executes a generic function. For example, extract odoo could be a function. That function lives in our reusable Python functions in the library, the custom library that we uploaded into the environment. This is something, this is the way that we tie together all of these components, and by layering our solutions like this or our processes like this, we get a really good control over what our solution is doing. And this also prevents us from having to program every time something changes, and from having to program when we start extending the solution. Maybe we want to add another source system that is just another function in the Python library, right? Maybe we want to add another table from an existing system. That's just a record in the configuration table. We don't need to do anything. Run multiple, and the orchestrator notebook will simply kick off an additional worker notebook when we run. In the end, the Python function is the thing that is connecting to the API, saving the JSON response to the lakehouse and so on. And we end up with a folder structure like this. So in our bronze lakehouse, we have files, then landing zone, then odoo, which is the source system. So we put a folder per source system in. Then we have this timestamp folder for every run that we do. So we go from year to second, so that we have a timestamp archive of all the extractions that we've done. And then we have a folder per table or endpoint. Why not a file per endpoint? It might happen that we get more than one file per extraction. A lot of APIs allow you to do 100 records per page or 1,000 records per page. Then we need to save maybe multiple pages for every table. So we usually put in a folder per table or a folder per endpoint. We have the file, so we decide what we name these folders, right? So from files to account analytic line, for example, is something that we, from metadata configurations, we decide how we name that folder structure. The files itself, we let it be managed by Fabric. So if Fabric sees that we're getting in many JSON files, we will simply get 0.json, 1.json, and so on. If Fabric is reading from a database and it is tens of millions of rows, and Fabric decides that it is smart to split up the Parquet files, we will let it split up the Parquet files. And we're not trying to fit everything in one file, or we're also not trying to outsmart Fabric and splitting things up in files. We will let the engine handle that.
Sorry, Bas.
Yeah.
We have a question online. So the question from Wilhelm is, have you experienced any issues writing tables from notebooks to schemas other than DBO? For some reason, I'm always experiencing a bit of pain when trying to write tables to other schemas. Views are fine, not a blocker, and I've learned to work around it. Just curious.
Yeah, so in this example that I have right here, we are writing into files, not into tables. But indeed, schema-enabled lakehouses are a thing now in Fabric. And I believe what we usually do is, first of all, your lakehouse itself should be schema-enabled. That's one thing. And then when you start writing into Delta tables in schemas, you have to a schema is basically just a folder under your tables. So you would put in schema name / table name if you start writing into Delta using schemas. And I've not seen any issues with that.
Thank you.
On the silver side, I've here created I took a screenshot of one of the tables that we had in our extraction. So from here you can see that the first folder in this timestamped extraction is called account analytic line, that contains I don't know, I think timesheet line entries or something like that. And from there, we create a delta table in the Silver Lakehouse. Now you can see that in this screenshot here, it's not a schema-enabled Lakehouse because there's tables directly under the tables folder. Otherwise, we would have DBO schema or maybe other schemas. In this case, that's not happening. But then again, we are moving from JSON files into a tabular format into delta tables right here. You can see that the tables have data types and so on, but you can also see that some of the automated extraction was not done really well because we have arrays here in the data. So account ID actually contains an ID and a name for whatever reason. I don't know why, but that should have been split by the process that is figuring out the schema evolution and so on. So usually that is something that I would like to do in Silver. Now on the gold layer, we will find data sets that are structured in no way that resemble the structures that we find in bronze and silver, or in the source system for that matter. So we see dimensions with customers' dates, projects, services. It was cut out of the screenshot here, but with fact tables that contain timesheet lines or invoice lines and things like that. We have naming conventions for our columns because those are the names that we will show our users in Power BI, right? We're not doing any translations of those names again, maybe translations between English and Dutch and German and so on, but definitely not renaming customer ID to client ID, for example. So the structure that we create here in the Gold Lakehouse should definitely be 100% the structure that we want to end up in our semantic model. And now how we go from silver to gold is we write a notebook containing a query that will transform that data. There's a screenshot in here that shows an example of such query. Now, end-to-end solution with some examples would look something like this. We have our main pipeline that we run, and that pipeline will basically invoke a whole bunch of different pipelines. And this is a very straightforward linear version. You can imagine that sometimes you might have to branch out to do parallel processing, to do whatever. You're free to do that using Fabric Data Factory. In this case, we do loggings at the start and at the end, and we do then process the bronze, silver, and gold layer. Looking at bronze, it starts the pipeline process bronze, and process bronze will copy some metadata, it will extract Odoo, and it will extract Moneybird. If we look at, for example, one of these pipelines, the extraction pipelines, we can see that we do a lookup against the metadata. We want to know what do we actually need to extract, and then it starts the bronze orchestrator notebook. We have that right here. That orchestrator notebook can look something like this, and now the screen is being recorded, I think, so you can watch this in your own time. And what we're doing here is we're basically using a bit of Python to find out what data do we actually need to process. We create a whole bunch, an array, or actually a list of activities, and then using MS Spark utils, which is renamed to notebook utils these days, we execute the method run multiple on that list of activities, and then all of those activities will run at the same time. Creating those activities looks something like this. You can pause the recording if you're watching this later on. On the silver side, and in the because of time, I will go a bit faster through the examples here. On the silver side, we basically do the same thing. We have a process silver, but we do not do this per source system because, again, silver processing is just technical processing on data type, schema evolution, time travel, and so on. So we can do that once for all the tables that we have in our system. Again, we do a lookup of metadata, then we process the silver orchestrator, and we go through the same thing. So we have an orchestrator workbook and a worker notebook for silver, and that workbook is actually running all the functions from the Python library that we have and that we need in order to do time travel and schema evolution and so on. Then on the gold layer, this is a bit more interesting. We have to import a few different functions. As you can see here on line 2, we import Kimura SK, and this is our custom library that we've created, and we can simply import it from that environment that we're running the notebook in. But from PySpark.sql.functions, we can also import code. That is not a library that we wrote. That's a library that's pre-included with Microsoft Fabric Runtime. So you can see here that you can mix and match any kind of Python libraries that you might need. And then our notebooks are really, really easy. The only piece of code that we actually write in our notebooks are the SQL queries in order to transform data. We do not write merge statements, truncate, insert, whatever kind of data handling that you might need to do in your stored procedures or notebooks. We will only write the mapping logic. So we map our silver layer data into a dimension or into a fact table. We need to know the name of our gold table, and we need to have a list of business key columns. And using those at the bottom, starting at line 28, you can see that we start merging then that data frame that we've created, the temporary table basically, into our gold table. Now the function k.goldLoadTable will actually create the table if it doesn't exist. It will load the table if it does exist, and it will do so through a Python merge. So it doesn't upsert based on the business key. Now, because we've put that into Python functions, we can simply put these 4 or 5 lines into every notebook without having to repeat all that merge logic for every table that we load. And then the mapping data frame itself, starting at line 6, ending at line 25, is just a SQL statement that we use to transform our data. Now, this is a very easy transformation. There is some renaming of fields going on, and then there is some apparently an MRR label that we say if the revenue group ID is a certain value, then it's licenses, otherwise it's other. But you can imagine that you can put any kind of business logic and calculations in here if you like. Here it is in full screen. Again, pause the recording if you want to follow along. And that is about it. We are now done with creating our first lakehouse. This was a lot. I ran over time a little bit, I see now, but I hope that things were clear. So let's do a quick recap. We have seen some core concepts in mind. We have to have our data warehouse solutions to be subject oriented, to be integrated across source systems, to be time variant so that we can do trend analysis, to be non-volatile, meaning only the ETL process should be able to write data. Then we have our rulebook that keeps ourselves on track. I will put in all the layers that we go through, the rules of processing, the types of tools and artifacts in Fabric that we use. Then we have seen how to use tools and reusable code, and mainly that it means next to your lake houses in Fabric, you would use an environment where you can upload custom code. So if you start writing code in your notebooks to interact with your lake house and you start doing it more than once, put it into a put it into a Python project and upload that to your environment, please. And Fabric Lakehouses aren't that scary. You can start working with them tomorrow. I would say today, but it's evening for you guys, so it will be tomorrow. But you really can start working with them tomorrow. If you have a Fabric capacity, spin up a lakehouse, start working with it. Start putting files into the file section, start writing little pieces of code. And yes, AI can help you with that really well. I mean, Python is the most documented programming language in the world. So it should be really easy to get started these days with Fabric Lakehouses. Thank you so much. If there's any questions, please let me know. And if you want to follow me, you can find me, Bas Land, on LinkedIn, but you can follow my YouTube as well. I started the YouTube channel a couple of months ago. I'm still growing it, so it would be awesome if you would follow that channel. You can find me at That Fabric Guy on YouTube, or scan the QR code to directly go to the channel. And I usually put little explainer videos on on several Fabric topics every week. So thank you for having me. And if there's any questions, let me know.
Thank you, Bas. Really, really enjoyed that. Very, very good presentation.
Thank you. Thank you.
I don't see any other questions. Oh wait, Elias has a question. I don't know if you can see the chat now, Bas.
Yes, I can.
Okay, so I'll let you read that question from Elias and give your answer.
There we are, Elias. in your workspace you had one for each layer. So is this for security and access control purpose, or did you have any other reasons for having separate workspaces? Yes, this is for security and access control purpose. Technically, you can very easily put all of your layers into one workspace. So you can have basically your bronze, silver, and gold lakehouse in the same workspace, and you can also have bronze, silver, and gold schemas into one lakehouse. However, doing so makes it more difficult to do granular access control. So yes, separating workspaces, simply making our lives a little bit easier for user control and security. Yep.
And if you don't mind me adding to that, there's another reason that for it is around the deployment pipelines. So using the deployment pipelines to manage your environments, you would need to separate those environments into different workspaces.
Yeah, for the DTAP you do, yes. Yep.
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 All right. I think everybody else is just saying thank you. And is there anybody who's got any final questions? Please feel free to come off mute and ask them rather than typing them in the chat. Any other questions for Bas? Right. Well, if not, we'll say goodbye for this month, and we'll see you again in May. I think it's May the 7th, if I'm not mistaken. That should be our next one. There is also potentially a very exciting one coming up in, I think it may be June, but Gilbert's currently dealing with that, the organization of that. But we have, without making any promises, a very real possibility of getting the Fabric Cat team in-person in Brisbane in the near future. So cool. That will obviously be a massive opportunity to meet some of the rock stars of the Fabric product team and the Cat team who support them. So yeah, look forward to that one, and we'll give you information as soon as we've got it. But have a safe month, everyone, and we will see you in about a month's time. Thank you.
All right. Thank you, guys. Cheers.
Thanks, Bas. Thanks, Craig.
Yeah.
Yep.